Another 30. My name is Paul Knight. So Ray told me to go ahead and introduce myself if he didn't make it back by 8 o'clock. We'll go ahead and try to get started on time. I'm working with Nortel Networks, and I'm wearing the hat here. Well, partly, since it's a black hat conference, I thought I'd wear the white hat. But also, I work a lot with the internet engineers, the IETF, and I usually wear my hat around the meetings there, so I figured if any of those folks are showing up here, at least you'd recognize me. I'll take that off now. But what I wanted to talk about today was something I've been working on quite a bit with the IETF, which is looking at dynamic routing within IPsec VPNs. So it's been an interesting area to work in because with IPsec, normally you have the IPsec defines security associations which are fixed. And when you try to apply dynamic routing, you don't get anywhere because your IPsec is doing some filtering and it really locks down the traffic that can be transported between the VPN sites. Okay, so what I'm going to be doing today, first talking about just some of the background of the IPsec topology that we'll be discussing, and make sure that we have kind of a level set of IPsec background. Now, one of the ways that you're supposed to be able to tell if you're explaining things well is if you can explain it to an 8-year-old. And I tried doing that, and I got most of the way through, and then got the question, what's an IP packet? And it was kind of hard to go back to the beginning. So I'm assuming everyone knows IP packets. I'm assuming you have a fairly reasonable understanding of what IPsec is trying to do. So we'll go from there. So I'll talk about the topology and then focus on how dynamic routing works within IPsec. And then the thing that I think this conference is most focused on is what are the security issues that come up once you introduce dynamic routing. So you're changing or at least using the IPsec model in a different way. So are you introducing some weaknesses? What are the weaknesses and how can you defend against them? Those are the things that I'm trying to cover today. Okay, in talking about the topology, IPsec topology background, I'll cover what's an IPsec gateway, what are the different modes, tunnel and transport mode, what's a security association, and then just talk about the different topologies. Okay. So the first possible topology here is host-to-host IPsec. So this is quite common, but I'm not going to consider that as a VPN, as a virtual private network. This is a system that certainly has its uses, but isn't part of a VPN. The branch-to-branch or site-to-site VPN is probably the most popular. And that's the basic model here. You have IPsec gateways that connect each of the trusted networks to the internet or to an untrusted network. This could be a carrier's network. So a lot of times, even if you have a carrier providing all of the IP transport, you may still want to use IPsec across the carrier's backbone. And then the final topology would just be remote access, where you have, say, like a laptop or PC. You could be sitting in the audience here with your laptop and connect through the net and through the internet to your home gateway. Okay, we'll go on to the two modes of IPsec, tunnel mode and transport mode. So here we're looking at an IP packet. And we've got a header which has its source and destination address and the data. So what is it that IPsec does? How does it do the encryption? Now this isn't going to be an IPsec tutorial, but I will try to explain a little bit about what's going on here. Within transport mode, which would be used between two hosts typically. You take the original IP header, the original source and destination address, and then you insert an IPsec. Typically it'll be an ESP, the Encapsulating Security Protocol, the ESP header. You can also do AH, the authentication header, but that's pretty much fallen into disfavor now. Not many people are using AH, so I'm just focusing on ESP, the Encapsulating Security Protocol. And then you have your data following. In most cases, your data is going to be encrypted, of course. In tunnel mode, you take your original packet, and it becomes the data for a new packet. So you have a new IP header. The source and destination addresses there are going to be your IPsec gateways. So your source gateway and your destination gateway. You'll have your IPsec header. And then, again, the original packet in its entirety is the data there. And this says optional encryption, but it's not really an option these days. You're going to be encrypting things. Okay, so some of the terminology, you have the outer IP header and the inner IP header. So how are we doing? Any questions so far? Feel free to interrupt me at any time if you have some questions. I'm not doing a good job scanning everybody, so wave your hand around or even yell if you want to. Again, my name's Paul. Just say Paul, and I'll try to answer your question. Okay, so let's look at where the different IPsec modes, the tunnel mode and transport mode, are used. So with the host-to-host, as I mentioned before, typically you'll use transport mode. You can use tunnel mode. It's certainly not prohibited to use between hosts. And then between gateways, the important thing when you're running between gateways is that you need to hide the addressing of the sites. So in order to do that, you've got to use tunnel mode. Now, it turns out you can also do something very similar to tunnel mode, which is where you do an IP encapsulation and then use a transport mode between the gateways. That actually has some nice benefits for the dynamic routing. And it turns out if you were to look at, take a sniffer, look at a packet on the wire, you wouldn't be able to tell any difference between the IP and IP encapsulation within transport mode and the tunnel mode. I'll talk a little bit more about that. All right, did you have anything that you wanted to say? Okay, I just went ahead and started, just like you said. Okay, the other mode that we talked about, or the other approach, is remote access. And in this case, you want to use tunnel mode in most cases. This allows you to assign an internal address to the client PC that can be used locally on the trusted network. In other words, it can become a full member of the trusted network, send and receive packets as if it were located on the trusted network, if it's using tunnel mode and has an internal address that is compatible with the trusted network. It would then use a tunnel encapsulation, use its real IP address or its external IP address as the encapsulating address there. Okay. The internal address in a nicely functioning system, the IPsec gateway can assign that internal address. Right now, there's not a standard way of doing that. There is some work being done on that, but it hasn't been fully standardized how to assign that internal address within an IPsec client to gateway connection. Now, another thing is it's possible to use transport mode to an application level gateway. In this case, the IPsec gateway is not really acting so much as a true IPsec gateway. It's acting more like a host. So it's talking as a host to the client, and then it acts as an application level gateway and forwards the packets, may do some transformation on them in order to get them to the destination. So this is really similar to the secure socket layer model. It places a lot of burden on the gateway. So again, the tunnel mode works out to produce a lot less of a load on the gateway in most cases. Okay, so within IPsec, one of the key things we need to focus on is what's a security association. And this is all of the information that defines an IPsec connection. So it has the ESP or authentication header algorithm that's going to be used, the encryption algorithm, maybe DES, triple DES, AES, which hash function, MD5 or whatever is going to be used in the connection. There's an exchange of authentication of the identities. All of this goes into creating a security association at the time that the IPsec connection is first established. Now, one of the reasons, I think we'll get into this a little bit better later, but because establishing a security association is fairly computationally intensive. You've got to do some exchange of Diffie-Hellman keys. You've got to do some fairly heavy computation. So you don't want to keep reestablishing your security associations all the time. That's one of the problems with dynamic routing in IPsec, is that if one possible approach would be simply to, when you receive a routing update, just reestablish new security associations with everyone based on the new routing information. But in a real, a large network, that's not very feasible. So that's one of the things we're trying to avoid in dynamic routing, is having to rebuild the security associations. Within the IPsec model, you have what are called security databases, and there's the security policy database, which is where you configure your policies, and security association database, which keeps information on the existing security associations that have been established. So this talks about what's in the security association database. The key points are there are three elements that are used as the identifier for the security association. So there's the destination IP address, the security protocol, whether it's ESP or AH, and then what's called the SPI security parameter index that's calculated at the time that the security association is established, and it's known by both ends. So that label is put on the packet at one end and recognized at the other end. The security policy database is going to be applied to every packet, and this is where all of the IPsec configuration, at the time that you set up your IPsec device, your IPsec gateway, all of your configuration information typically feeds into the security policy database, all of your security configuration anyway. So this can really determines the processing, whether you encrypt a packet, whether you discard it, and so on. So let's look at how the databases are used. When you have a packet, okay, this is a packet that is inbound. It's coming in from the untrusted network. It's already been sent by the partner gateway. So when that packet comes in, we look at three things: the destination IP address, the security protocol, the ESP or AH, and the SPI, and that identifies the packet for the security association database, which then passes it over. It will decrypt the packet and then pass it on to the security policy database, which then looks and see if this is an allowable packet. So the security policy database, of course, or that function, can't look at the packet until it's been decrypted. So it kind of makes sense. And then the packet gets passed through. The IPsec part is removed and it's passed on through. And the reverse is done when a packet is sent out. Now, the reason I'm going through this, I'm really not trying to teach you all about IPsec, but it's fairly important in looking at how dynamic routing works to understand how these databases are involved in the operation. So, just want to make sure that we have this information. Okay, so when we're sending a packet out from the trusted network out across the internet or untrusted network, the first thing we do is look at the packet and compare it with our security policy database, see if it's something that we should be sending out, see if we have an existing security association, and if we don't have an existing security association for this particular packet, for the destination that it's going to, then we'll have to begin the negotiation with the other gateway or with a potential other gateway and establish a new security association for it. Then we would put that information into the security association database and send the packet out. Okay. Any questions so far? Okay, so now we've kind of talked about IPsec, some of the functions that are going on in IPsec. We looked at the topologies that we'll be covering, which are the two VPN topologies. Again, we're not looking at IPsec host to host, but either typically from gateway to gateway between sites in a virtual private network or as remote access to the virtual private network. Okay, so let's look at how dynamic routing fits in here. First of all, why is it important? Well, anytime you have a sizable network, it's really hard to manage the network without dynamic routing. If you have IPsec gateways, you've got to reconfigure the gateways every time you add a new subnet or a new network to one of the sites. So you can have automated systems, a management system that can do this automatically. But at the same time, while that's being done, you're going to be disrupting your existing security associations. There have to be, if you're doing this strictly according to, strictly with IPsec without dynamic routing, then you've got to establish a separate security association for each network that's defined. So all of these things, load balancing, failover, change management, they all make it really hard to manage a network without dynamic routing. So when I first started working with trying to get some standards set up around dynamic routing, one of the first questions that came up was, why do we need something? Why do we need to standardize something? Can't we already send routing information through IPsec? And it's true, you can. If you have a router behind an IPsec gateway, it can send a packet through the IPsec gateway. It can send routing information through a gateway to another site. But the trouble is that the IPsec gateways, even if they're the ones doing the routing, they can't use that routing information in a straightforward way. In other words, so I got a diagram that shows that a little bit better. And the key point is that the IPsec statically defines the networks by the security associations that have been established. And in order to do that, you've got to have some interaction between the routing protocol and the security associations, which is not good. You don't want to have to keep rebuilding the security associations, or you've got to find another way to work this, and that's what we'll be getting into here. So there are three. I think there may be another one now. Anyway, there are three internet drafts that describe this in fairly good detail. I think in your big red book there, if you carried it in here, my draft, the draft night PPVPN IPsec dynamic routing. Anyway, that one is printed in your book there. The others are available on the internet. You can see the URL there. So where the big X is, you stick the name of the file. So that goes into a lot more detail about what's going on here. Okay. And I think I've covered most of those other issues. In particular, that we don't want to be dynamically changing the security associations. In a large network, that would really slow things down, and it would also introduce some other potential problems. If you're renegotiating the security associations frequently, then that could open a lot of potential denial of service attacks. Okay. In terms of a topology for some of the following slides, this is what's going on in the background. So we've got, I'll be showing connections kind of between, say, site A to site X and Y and Z. These are going through an internet or through a carrier's network. There are lots and lots of devices in that network. So these aren't devices that are directly connected. We're going across a network with a lot of devices, possibly through multiple ASs, autonomous systems, between different carriers and so on. Okay, so these are some of the issues, some of the reasons why, again, why we need dynamic routing. If, say, the site Z adds a new segment and decides that it wants to use a new IP network range that hasn't been advertised before, it needs to find some way to advertise that back to the other sites. It can either do that, again, through an IPsec management system, which goes through and then reconfigures each one of the gateways at each of the sites, or it can use dynamic routing. And this is a kind of a graphic look at the issue, what's going on. If between site A and site X, let's say there are two networks on site X. That means we need to have two security association pairs. Actually, a security association is a unidirectional mechanism. So you need to have really a pair of security associations to make one bidirectional connection. So we've got two pairs of security associations going to site X, one to site Y, maybe there's just one network there, and three in site Z. The outbound traffic, as it goes through the security policy database, at that point it's determined where the packet's going to go, and it does a lookup in the security association database and sends it on out. Now it's possible, if you, again, as I mentioned, if you had a router sitting behind these or even in association with the gateways kind of built into them, you can exchange routes, but there's no defined way within IPsec for that route exchange to go in and modify the security associations. Now someone could come up with a way to do that, but it would be very difficult to make that interoperable. So what we were looking for when we came up with the dynamic routing approach was to make sure that we did something that could be interoperable, that wouldn't require only a single vendor's equipment, and that wouldn't require, that wouldn't be likely to run into trouble if you're connected to a piece of equipment that doesn't implement things perfectly. So this approach is not very flexible right here. So the basic solution, in order to overcome the static routes that are defined within, that are essentially the way IPsec works, you can, what you need to do is use a wildcard as you set up your tunnels. So there are really two ways to do it. You can use a tunnel mode security association, set it up as a wildcard, which means it allows any source to any destination, or you can use encapsulation to make the traffic fit into the connection. So once you use encapsulation, then you can set the destination address to be the IPsec gateway that the packet needs to go to. This is IP in IP encapsulation over a transport mode. This has been called IIP TRAN. It can also be done with the GRE, generic routing encapsulation, which is another encapsulation. It's a little bit heavier encapsulation protocol. It has its own state machine, so it's really not the best solution, although it can work here. And both of the approaches, using a wildcard in a tunnel mode or using encapsulation within a transport mode connection, both of those are quite similar. But we found after really looking at this that the encapsulation within a transport mode offers the best combination of functionality with the least possible change to IPsec. In fact, it doesn't require any change to IPsec. You simply encapsulate the packet before you hand it to IPsec, so there's no change at all to IPsec within the tunnel, within the transport mode approach. So, okay, in either case, what this implies is that you have to do your routing before you do the IPsec. So you've got to have a system that's able to do routing with full routing capabilities as well as doing the IPsec. And essentially it looks like this. One way to think about it is that the outbound traffic first goes through a routing function. Now, I've got a big box around this to show that this is all one device, the IPsec gateway at site A. So you've got the routing functionality in there, and it determines where the traffic's going to go, and then hands it to the IPsec functionality. You can think of it as separate security policy database and security association databases that are along the path. It can also there are different ways of thinking about this, and I'm still kind of going over the best way to represent this. So I'm hoping this comes across okay. This shows also that the routing exchange, then, I've drawn a little router at each one of the sites, can use OSPF, RIP, RIP2. IS to IS is not well defined at this point. We're still, in the IETF, we're working on a way to carry IS-IS purely within IP, but IS-IS is not an IP protocol at this point, so it can't be used at this point in exactly this way. But OSPF, RIP, BGP, of course, is no problem at all because it doesn't require any kind of adjacency. Okay, the next thing I want to focus on is the fact that tunnel mode, which is a requirement for gateway-to-gateway IPsec, is the same thing as transport mode with IP encapsulation. This is it's a key concept for dynamic routing, and the focus here is determining. You use your routing to determine the next IPsec hop, in other words, the next IPsec gateway that the packet's going to go to. And this can be using any criteria for the packet. You can look at what the protocol is. You can have FTP, following one path, Telnet following another path, Mail following another security association if you want to. So all of the things that you can define within IPsec as selectors can be used to influence the routing. Then once you've determined where you want the packet to go, you construct an encapsulating header with the destination address for that, and then pass it to a transport mode IPsec connection. It's already encapsulated, and then that resulting packet is equivalent to tunnel mode. But at this point, it's going to be handled using the dynamic routing updates that feed into the routing process. Any questions about that? Okay, maybe a little bit early. That's one of the advantages, I think, of trying to talk the first thing in the morning. Everyone's maybe still waking up. But please feel free to interrupt if you have a question. Okay, so let's look at that maybe a little bit more graphic way. So transport mode, again, we looked at this a little earlier. You have the original IP header, and then you have an ESP header and the data. So we start with, we'll do the transformation and show how we end up with the same thing as tunnel mode. So we start with a basic packet, do the IP and IP encapsulation. So this simply puts a new header on it. This is going to have the source address is going to be based on the gateway that's sending the packet. The destination address is going to be the destination gateway. the entire original packet becomes data, the data field of this new packet. And now when we do the transport mode processing, in other words, we take the original, or we take that new data, it becomes the data field. So we have a new IP header that's simply being moved out because we've already determined what that IP header is. We did that using our routing process when we did the encapsulation. Okay, and then if we were to go back and look at the slide where I showed what transport mode looks like, it would be exactly the same. And we've done some testing. You know, the packets are exactly the same. Again, have good interoperability. This, okay. So again, the data, the original packet there is the data for this new transport mode connection. And it's encrypted. Okay. So some of the terminology that's used, this is called a VPN tunnel. And we call it a tunnel even though it can be used, it can be based on transport mode. So essentially the IPsec connection itself is no longer applying the address filters. So your routing functionality is selecting what packets are going to go there. You need to make sure that you have all of the packet filtering, all of the firewall functionality that you might expect in IPsec. Firewall functionality is not part of IPsec, but all of the filtering capability of IPsec, all that needs to be done before you hand over the packet to IPsec. Okay, so let's see. This can be either IPsec tunnel mode or IP and IP over transport mode. Allows any traffic. In particular, it allows the routing protocols to pass, so that OSPF, which is multicast based, can be encapsulated and sent over this perfectly well. The endpoints are the IPsec gateway interfaces. So all of the traffic is protected with encryption. It's full IPsec protection there. And the way to think of this is a replacement for, or it operates the same as any link connection, as Ethernet, ATM, or frame relay, but it's all secured by IPsec over an untrusted IP network. Okay, and again, since you're not using the IPsec tunnel definitions to select the destinations, you've got to do the routing before the traffic goes in here. Okay, so the basic functionality here is you need to do, so the routing needs to be done inside the IPsec gateway with traffic and route filters. You need to be able to set up routing policy with this routing functionality. You need to be able to separate the VPN routes from the external routes. So you've got to manage really a couple of routing tables. You'll be receiving some routes from the public network. If you're, say, multi-homed to the internet, you need to be getting those routes, but you need to make sure you're keeping those separate from the routes that you learn through your routing protocol, through IPsec. Okay. The other thing in the way the gateway equipment is designed, you need to be able to use the endpoint of the IPsec VPN tunnel as just like any IP-capable interface. Kind of gets into the definition of how routers are constructed, but it needs to be able to that IP address needs to be able to pass routed traffic and also send and receive routing protocols. Okay. Okay, so let's take a look now at the attack and what issues arise when you start using dynamic routing, and what are the defenses. Any questions about the basic function of dynamic routing in IPsec? Okay, good. Maybe you've all read over these things and you're really up to speed with it. So good, thank you. Okay. So first, I'll take a quick look at what are the issues with remote access when you're using the remote access model for VPNs. The big issue here is what's called split tunneling. And I'll define two ways of doing this. One is a captive tunnel, in which the client's default route points into the tunnel to the IPsec gateway, and other routes aren't allowed. And the other is a split tunnel, where the client can send packets to the gateway, or it could send packets into the untrusted network. I'll get into a little bit more detail of that later. The other issue that comes up with client access is denial of service attacks, and so your gateway has got to be able to deal with those issues. But that's really not what I'm going to try to talk about today. So denial of service attacks is kind of something you're familiar with from a lot of sources. So I'm not going to try to approach that. So let's take a quick look at what split tunneling is. If you don't have split tunneling, then at the time that the client connects to the IPsec gateway, the IPsec gateway forces essentially a default route into the client, so that every packet that the client sends out is going to be tunneled, encapsulated, and sent only to the IPsec gateway. That's the only place that it can send packets. If you do that, and this is really a policy decision at the time you set this up, and then what that means is if the client wants to go to a host on the internet, that it needs to go through the corporate site and come out through the firewall, just as if it were a host sitting on that corporate site. That may be something that you want to do. It may not. With split tunneling, the client is able to send packets either to the IPsec gateway or directly to the internet. So in this case, the routing information that's sent down to the client would simply be routing information about the trusted network. So the routes that are in the trusted network would be sent to the client, and those routes would point to the tunnel or to the IPsec connection. All the other routes and the default route of the client would be left so that it points to the internet. So what are some of the issues with that? So why would you want to allow split tunneling? Obviously, you're wasting bandwidth to some extent if the client's packets have to go through the trusted site or through typically a corporate site. You could block the client so that it doesn't get to the internet at all if it's connected through the VPN. One of the reasons why you might want to allow split tunneling is, and this was kind of interesting. We found this. We were doing some work with. Actually, this was with Intel, and they had a lot of, or a number of people who were working from home for extended periods. And the ISP they were using gave very short leases with their PPPoE client. Not sure what happened there. And so the leases were in the range of something like 8 hours, not terribly short. But we found people were keeping their client connection up for more than 8 hours, then were getting shut off because they weren't able to talk to the DHCP server and renew their lease. So this became one of the drivers for allowing split tunneling, even though split tunneling has some serious or some security considerations. Okay. So what are the attacks with split tunneling? One key approach is FTP relay through the client. If you've got a client that's able to talk both to the internet and to a corporate network or to a trusted network, then it can become a relay for various kinds of attacks. FTP relay is one that popped up immediately, but could have SMTP or some custom designed application that could have the same effect. Remote access Trojan or some kind of remote control of the client PC also might be a possibility if you allow traffic from that client to the internet at the same time that it's talking to the trusted network. So what are the defenses? You can turn off split tunneling. That's an obvious way, and that's actually within Nortel networks. That's what we do. We just turn off split tunneling for when we're using the client access into the corporate gateway. This requires that close interaction between the client software and the gateway, so that it's not something you can do with every client and gateway. So part of the way this works is that the software on the client looks at the routing table on the client and reports to the gateway and blocks the access. So this prevents someone from using their client, setting up their own routing on the client and kind of getting around the routes that are passed down. It's fairly easy to go into your routing table on the PC and do that, but the client software can look at that and make sure that that's not allowed. Also, the gateway system can look at the traffic coming from the client and see if there's an unexpected port that's open on the client. So again, the client software is involved with this to do some monitoring on the client PC. So a lot of this depends on the capabilities of the client software and how well it can actually determine the state of the machine. So with multi-processing systems, this becomes a little bit more difficult. So again, just stopping split tunneling is one of the better ways to control what's going on. Okay, now let's look at the branch-to-branch model of the VPN. So I'm getting away from the remote access VPN and moving to the branch-to-branch VPN issues. So I've shown firewall next to the IPsec gateway. This might actually be a single device. So it could be a combined device that does the IPsec gateway functionality and the firewall. So some of the questions are, where does the default route point? What can happen with misconfiguration? What can happen with an internal routing attack? So the biggest issue when you're using dynamic routing with IPsec is that the traffic might be forced over an unprotected path. It could go, if the routing can be fiddled with or affected, then the traffic could go toward the wrong destination where it might be intercepted. And again, following the wrong path toward the correct destination, this would typically be following a default route through the internet and then going back into the other gateway through without passing through the IPsec functionality. Okay. So how can routing attacks be made? It could be simply injecting routes. If you're using an older routing protocol like RIP, it's incredibly easy to set up almost any system with route D and start talking to the routers nearby. OSPF is a little bit harder, but all of these things, let's see, misconfiguration can be a big issue as well. So these are things that that you need to be especially careful of when you're using dynamic routing. Just like within any network, if you already have a VPN set up, you're using leased lines, you've still got the same issues. So these aren't particularly new issues that are introduced by IPsec, by dynamic routing in IPsec, but these are some of the key issues. In particular, the default route. If you if you're using dynamic routing and you lose the routing information for one site, and then you start going through the default route, that's really the biggest thing to be concerned about. So look for issues related to that, in addition, of course, to the possible malicious issues. So some of the protections against routing attacks, these are fairly well known. Routing authentication, you can use a hash like MD5, particularly with OSPF. You can use a digital signature, and there's also work going on in the IETF on secure routing in general, which allows tracing of the source of routes to make it a lot more difficult to attack the routing this way. You can do audits, you look at the route tables on a frequent basis. Using the default route, the key point is just making sure that traffic which should be going through an encrypted link is not going to go out through the default route. And all of these points here point in that direction. The key issue is that you need to have policies which would be set up on your firewall to make sure that your known internal destinations don't get routed through the internet. Those policies would need to be updated and kept up to date when you add new networks. Okay, so the basic functionality, or the basic requirement here to allow dynamic routing within IPsec and make sure that you're still maintaining your security is you need to have the firewall functionality within the device, you need to have the routing functionality within your device, you need to be able to do the encapsulation and in the proper way so that you're using the full protection of IPsec. Again, these are the basic functionality that you need: firewall, router functionality, and the ability to do the dynamic routing using IPsec by using your routing information to affect the encapsulation. The encapsulation then feeds directly into IPsec with a transport mode connection, and it just is routed naturally through IPsec to the destination. So this is the conclusion, pretty much what I've said. Dynamic routing is very helpful, but you can't just add routing to an IPsec box and feel that you can do it securely. You've got to have firewall functionality, you've got to have very flexible routing functionality to filter the routes that you receive, make sure that you're not being misled or spoofed. And you've got to, if you have remote access capabilities, you've got to make sure that gets locked down as well. So I don't have a lot of time for questions, but if you have any questions, thanks very much. Okay, so run out and get yourself some more coffee before the next session here. Thanks.